All right, here we go. All right. Boy, I hate it. I need to do it this way. Reconfigure all this. Okay. All right, here we go. All right, statistics. It's okay. Don't be sorry. The science of collecting organizing, summarizing, and analyzing. Information. To draw conclusions. Like I said, you guys have a lot of words to remember the definition of. Data. Is a fact used to draw a conclusion. Population. Entire group. Of individuals. Individual is a person or object that is a member of the population. I know that some of these definitions are kind of like, yeah, I already know that, dude. Sample. There's a subset. Here, let me do this before. I'll let you guys take a picture of it in just a second here. Subset of the population. Okay, do one more question there before I let you guys take it. No, let's go ahead and do that. You guys need to take a picture, go for it. Okay. Descriptive statistics. Describe data through wow. Numerical summaries. Tables and graphs. Inferential statistics uses the results from a sample and extends them to the population. And measures the reliability of results. So inferential statistics happen all the time. Obviously, when they look at like who's watching, how many million people are watching a particular show, right? Like Friends. If anybody watch Friends. They usually take a small population and they find out if those households are watching it, right? So let's say if they go out and look at 30 households and 28 of them are doing that, they would just then say, so, whatever that percentage is, the 28 out of 30, and they'll extend that to 30 million people, that 28 million people were actually watching Friends. That's different. All right. Parameter. A numerical do this. I have to understand that now that this is the first draft of the notes, that I have to be somewhat orderly and neat. So before I get to variable, because if you were to read the definition of parameter and to read the definition of statistic, they sound the same. Because a numerical summary of a population can sound like a statistic. Understand that they're different. A parameter is the fact that we already know. We already know this fact. We look in this room, I can tell you the percentage of students that are repeat students of mine. It's a fact. Does that make sense? Okay, I can count number of students, total number of students, how many students are repeating one of my math classes, and then I can give you a percent. Right? Statistic is going out and let's say during one of these student socials out here on the lawn, and they kind of there's a crowd of 10 people and they just take a statistic of these 10 people. And now from there, infer that on this campus, chances of a student that came from Chan's math class will repeat one of his math class is this percentage. Does that make sense? Okay, that is a statistic. They actually surveyed so many people and it infer that information forward to the whole population. Where here with parameter, it's a fact. It's already, I can count this. I'm not taking a survey. I can count it. Okay. So that's the difference between parameter and statistic. All right. And apparently, when I talk to the other statistics professors, apparently parameter and statistics is where students get confused about which one is which. Okay, variable is a characteristic of the individual within the population. That ready for another? I think that's ready for another picture. Good. More screenshots. Then the tool. Qualitative. variables. Allow for classification of individuals based on some attributes or characteristics. If there's qualitative, there must be quantitative. By numerical measures of individuals. No, no. I'm just trying to figure out, like,
I think she realized she was probably in the wrong. She was going in the wrong way.
because it doesn't sound like Spanish. Man, that kind of doesn't sound like Spanish, so it must not be. So if you guys know qualitative, obviously quality, right? Quantitative, quantity, right? So the quantitative measures can be added into or taken away from, right? Which is done quite a bit as well, especially with the mobilization of COVID. I mean, that's not true. Actually, what time does this class end?
9:58.
Huh?
9:50.
I was like, did I go past? I thought someone said 9:38, so I can figure this. Awesome.
It's got shorter in the regular classes.
Say that again?
It's shorter than the regular classes.
It is. So this is like college algebra in terms of span of time.
Oh,
Right? It's only a 3-credit course. 4-credit course is almost 2 hours. So a lot depends on how many credits it is. Okay, let's finish this then. I know, a lot of definition, right? A whole lot of the definition. Okay, discrete variables. Wow. The quantitative variable that has a finite number of possibilities. Or possible values. I should say. While we have the continuous. Which is also a quantitative. Take a picture, go for it. So when you're talking about the quantitative variable, obviously there is two different variables that comes off of that, which is the discrete and the continuous. All right. So the word finite means you can actually count them. Okay. So like the students on that are registered at FSW, that's countable. I should say that the number of students at FSW fall 2022, that's countable. The number of students that has come and will come to FSW to be a student, that will be continuous, right? Because obviously time goes on. That won't be countable. Eventually it will be, but there's a stop of time. But then time continues on, it will be continuous. Make sense? All right. I'm going to stop right there. Now, the first chapter is just like this. It's a lot of definition. When we get into, I'm going to stop.